Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
So good morning, I should say good afternoon, everyone. My name's Carol Fletcher, and I'm here with my colleague Anasol Peña-Rios, and we are both really pleased to be here today to talk to you a little bit about how BT does research, why BT does research, and also how we collaborate with our academic partners. So I'm going to tell you a bit about the background of BT, our kind of innovation heritage, some of our key problems, and then Anasol is going to talk a bit about a couple of particular collaborations that we have going on with Swansea University and with Cardiff University. So first of all, a little bit of a history lesson, and this is quite a bold statement to put on an opening slide, that purposeful innovation in telecoms has been transforming the world since 1837, and this really illustrates how BT approaches research and how we do research, and it goes back to 1837 and to this patent which was filed by Cook and Wheatstone. So any engineers who are listening probably were familiar with Wheatstone from the Wheatstone Bridge, and his partner here was a guy called William Fothergill Cook. He was probably call him an entrepreneur today, and they patented a way of using electromagnetism to communicate, so the electric telegraph. So they were around at the same time as people like Michael Faraday. They were fascinated by the kind of the new discoveries that were being made in the world of electromagnetism, and what they did was made that link between science, the breakthroughs that were being made, and some practical engineering know-how, and used it together for a purpose. And in this case, that purpose was communication. And that patent, we can trace back BT's origins to the filing of that patent and the subsequent founding of a company called the Electric Telegraph Company, which was a predecessor of BT. So that makes us the oldest telecoms company in the world. And that approach to innovation in those 184 years, I think I've done my maths right there, that approach to innovation hasn't changed. We are still about marrying science, discovery science coming out of university or other labs, with some practical engineering, and most importantly, putting those together to solve a problem, to have a purpose. And just going back through from 1837, some key milestones along the way that we've passed. I'm not going to go through all of these, but just a few to point out some kind of firsts that we've made. So 1926. That was the first two-way transatlantic telephone call. So that was the first time that a human in the UK had spoken in real time to a human in the US. And it was done by radio, so it was a mobile call, something you might not have expected. Another milestone along our journey, 1943, and that was the Colossus. So Colossus was invented by a post office engineer called Tommy Flower, so that was a predecessor of BT. And Tommy had identified a way of using valves in order to make an electronic programmable computer. And he identified that this was an interesting way to help the code breakers, so people like Alan Turing, who were using complicated maths to try and break the German codes. And by using Colossus, they were able to break the Lorenz cipher, and historians tell us that brought forward the end of the Second World War, probably by about 2 years. And I've mentioned Tommy because he's a bit of a rock star engineer to us all at BT, and I will tell you a little bit more about some of his legacy later. Just moving on with some of the other things. 1984, single mode optical fiber. So BT did not invent single mode optical fiber, but what we did do was we made it usable. So we worked in terms of refining the manufacturing process, refining the way it was being made and how it was being used in order to make it usable. 1984, the two illustrious locations of Milton Keynes and Luton were the first in the world to be joined by a single mode optical fiber. And that's the same kind of fiber, hair-thin strands of fiber, about sort of few microns in diameter, that still is the backbone of the whole world's communications network today. Coming a bit more up to date, one of the things that we're doing right now, started this month in fact, is a world first evaluation of something called hollow core fiber. So traditional optical fiber is a solid thin strand of glass. This fiber actually has a hollow core, so the inside it is air, and we're looking at ways of using that kind of fibre where the light will actually travel down the air core rather than through the glass itself as a way to communicate. And there's potentially some great leaps forward in terms of latency or delay, but also in terms of the kinds of bandwidths that we might be able to get from this kind of fibre. And that has great implications, particularly as we start to go into a world where we might start to see things like quantum computers. So that's enough of the history. Let me tell you a little bit about our credentials. So we spend about £500 million a year as a company, a little bit more sometimes, on R&D. We are a research active company, so we file patents and we have a portfolio of over 5,000 of those. In terms of AI patents, that's an area of particular interest to our research. We are the highest UK-based applicant for AI patents with the UK Patent Office, and that includes being, higher than not only other companies, but also universities and other academic institutions. And we have relationships with over 30 universities, mostly in the UK, but some overseas. And we really work together to collaborate, to do research, to move science forward, and to build more of that purposeful innovation that I just talked about. So one question that you might be pondering is, BT is not a manufacturer, and generally companies that do research are, companies that make stuff. So they might make cars, electronics, pharmaceuticals. Why are you BT? Why are you doing research? Well, one of the reasons is sort of understanding the future potential of what technology could mean for the way we communicate and therefore mean for our business. We also live in a world where as a company, we rely on equipment that's made by other companies, and we want to make sure that those companies are making and selling what we want to buy and not just what they need to sell us. So we want to make sure that we understand how it works so that we can be really informed buyers, informed purchasers, but also to make sure that we can push those companies to really make sure they're kind of sweating that technology to get the most out of it. Telecoms is very much a standards-based industry. So we have international standards, which means that our systems interoperate from different countries, which is what drives economies of scale. And again, being an informed buyer, an informed purchaser, an informed contributor to those standards is very much driven by our research. So this is where I am today. Our labs, which is at Adastral Park in Suffolk, it's our global engineering HQ. It's the largest test and integration facility in Europe, and it's home in normal times to around 4,000 people every day, around 2,500 who work for BT, another 500 Openreach, and then about 1,000 other people who work for 150 plus other companies who are based on the park with us in a high-tech cluster. So they have some sort of link to the ICT and the telecom sector. They range from very much from one person, small companies, right up to big multinational names that you will have heard of. And we're not just a place where R&D happens, we're very much a centre of collaboration. So we have around 60,000 visitors a year, again, in normal times. And they range from, the CEOs of some of our major global customers who we bring around to, show them our thought leadership and show them what the next possibilities are, down to children of primary school age, because we're really passionate about driving interest in science and technology and engineering and maths, which is going to be so important for the next generation of technologists and for kind of continuing the kind of business that we're in. As well as Adastral Park, we have a number of other smaller presences, but still significant research centres around the world. So we have MIT, we have BT Island Innovation Centre in Belfast, and we have a joint venture with Etisalat, who are the incumbent telecoms operator in the UAE. That's based in Abu Dhabi, called EBTIC. We have an Indian research centre in Bangalore and a China research centre in Beijing. And I mentioned already that we have these sort of 30 plus relationships with universities and business schools around the world. And we work with them, in a very much a kind of symbiotic way. So we work with them to get access to some real world-class expertise that we don't necessarily have. Sometimes also to get access to some world-class facilities and equipment and labs that we don't necessarily have. And on the flip side of that, the academics get involved with us and they get access to facilities and data and things that we have, and also to our people who may have skills and an industry perspective that they don't have in their own institutions. We see working with universities as a really important way of identifying sort of challenging new ideas and making sure that the ideas that we come up with are being kind of properly thought through. They're being challenged by others who are experts in the field, and we're not just sort of taking the word of our own experts without really thinking about it. What university research tends to have a much broader view and a much longer timescale than some of our in-house research does, and it's a great way of starting work in a new area, of building new skills. And we have a great track record of bringing in talent, particularly STEM talent from our university partners, both as graduates and also postgraduates. So how do we work with universities? Well, one of the things we don't do is contract research. So we don't just, pay some money to a university to do some work and come back when they've finished. Every time we work with a university, we are very much in there. Our people are working with them, whether that be through PhD sponsorship or bigger projects. We have 4 strategic university partners who are Cambridge, Bristol, MIT, and Tsinghua in China. Those relationships are quite deep. They're quite kind of multidisciplinary, multifaceted. Our other university relationships can be around a particular department, a particular team, a particular academic, depending on the situation. And what we look for when we work with a university is 2 things, really. One of them is, are they really good at what they're doing? Are they doing something really good, really interesting, really a bit different to other organizations? And secondly is, are they an academic or an academic team that we can work with? So do they kind of understand how the pressures of industry research might be a bit different, for example, to academic research? The kinds of outcomes that we're looking for might be a little bit different. Just to give an example of some of the ways that we work with universities, so obviously in collaborative research projects, we sponsor PhDs. We work jointly with universities in both EU and Innovate UK funded projects. We have a large number of our people who have visiting positions at universities, whether they be professorships, fellowships, visiting lecturers, and we give many guest lectures, talks, and seminars to our university partners every year. We're also called on to kind of influence curriculum and course content, and also we sit on quite a number of industry advisory boards and panels to sort of bring that industry perspective in, but also to understand what's happening in the university and bring that learning back out into BT. It's a big source of new talent brought into the business for us, our working with universities, but it's also a source of great thought leadership for us as a business, and bringing along new technologies, new ideas, and really kind of testing them out as well. So one thing I wanted to mention was the Tommy Flowers Network. I mentioned Tommy Flowers earlier. So this is something that we launched in 2016, and it's about bringing together academia and industry, not just BT, but all industry, to really help develop those kind of doctoral and postdoctoral researchers who are going to be the research leaders of the future, whether that's in industry or in academia, and help them to build the skills and work together on some of the kinds of key problems that the world is facing. Actually, currently, right now, we're running one of our free conferences. We run a number of conferences which are free to attend every year. It's around smart connected manufacturing, or Industry 4.0. And we've run other conferences on subjects like the future of security, on the future of TV, on transport. So anyone could come to those conferences. And we're hoping that they'll return to being a sort of hybrid virtual and real presence soon. We also run a thought leadership program where we invite visiting academics to come and do a bit of a deep dive on their research. And that the audience for that is people right across BT's business, but also to many of our customers, our other academic partners, and other partners in the Tommy Flowers Network. And just to give you an idea of some of the kinds of topics, they're fairly wide ranging. So you can see recently we've looked at, agri-food robot revolutions, how technology could help our mental health, the North Sea supply chain, and also intelligent asset management. So quite a number of those. If you're interested in getting involved with Tommy Flowers, then you can Google the Tommy Flowers Network, or use whichever search engine you like, or you can link with me on LinkedIn, and I'm very happy to send you details. So I want to talk a bit now about our research challenges. What are they? What are we interested in as a business? I mean, our research interests are wide and quite varied. So probably not surprised that we do research in the area of networks, both fixed networks, optics, mobile, Wi-Fi, but also that we're interested in things like cybersecurity, in AI and data science, in the future of TV and content, because of course we're a TV business now, as well as being a communications provider, and we're also interested in things like the Internet of Things. And if you like, our challenges are thinking about how we might grow and build as a business. So connectivity is what we're known for. It's what we do now. So making sure we can offer the best connectivity is a challenge. And one of the biggest challenges around that is people wanting better bandwidth, lower latency, better connectivity, but not necessarily paying any more for it. So doing that in a way that that makes that kind of growth of data on the network really sustainable. And people don't just want to connect; they want that connectivity to be a trusted way of connecting. So that's not just about the security of the link and making sure it's not being able to be hacked, for example, but it's all about being able to understand that the partners on the other end are who they say they are, and you can trust that communication. So that's the kind of next layer, if you like, building up from just about connectivity. It's also about trusted connectivity. And it's about using that trusted connectivity to kind of generate actionable insights. So, we carry data over the network, but carrying that data to a place and doing things with it using AI or data science, which kind of really leads to actionable insight for the person, for the business, for the organization who's using that link. And then finally, it's all about really driving productivity, whether that's personal productivity, so helping you to make better use of your own time, or productivity as a business, sort of through optimizing operations. And you can see how some of the kind of areas that I've listed on the right of the slide there. So things like, autonomous transport, improving safety and security, sustainable smart cities, energy distribution, really build on those four kind of areas of connectivity through to being trusted connectivity, generating actionable insight, and driving productivity. Just want to talk about a few examples of some of the kinds of work that we're doing. So that the first is AI. I mentioned that that's a really important area for us. So probably think of us as a business that runs a network, and absolutely we have a very big network. But networks now are very much driven by software, and software is very much being driven and influenced by AI. So applying AI to our network is a really important area for us. Our operation is huge. We have 30,000 field engineers. We have large numbers of customers, large numbers of pieces of equipment and exchanges and things out in the field. So one of the things that we're looking to do, and are doing with some success, is applying that AI and data science to really optimize our operations, to try and predict when things might happen, to recognize when things might be happening, to be trying to be really smart in the way that we do things. So a few examples there. We've made some great use of particularly fuzzy logic systems in optimizing our field operations. So those 30,000 engineers who are moving around the country in vans, understanding how we schedule them, how we decide which job they do next, how many we have on shift at any one time, what's happening with things like the weather and how that might influence, how that works. AI also has a huge role to play in our cybersecurity operations, particularly in understanding, for example, which cyber attacks are the ones we need to be really interested in, and which ones might be more likely to fizzle out because they might be a bit more amateur in their nature. Is an important role in detecting nuisance calls and understanding, behaviours that might be coming through. We might spot from particular networks or particular numbers, and identifying that they might be kind of nuisance calls. We're also deploying AI to look at our network, look at the data from that network, and be able to diagnose problems, perhaps predict problems before they happen, or mean when a problem does happen, we're pretty sure straight away what it is, and we can get that sorted. Also using it for our own internal systems on things like our software to look at, are we being as productive as we could be? Are our processes optimized? So that's AI. Going to flip to a very different area now, and that's the area of security. So I mentioned quantum computing earlier, and one of the challenges that quantum computing is going to bring when it's more widely deployed is that the kind of current algorithms that we use to encrypt data, to secure data when it's being transmitted, not just BT, but everybody who encrypts data, is that those algorithms are likely to be able to be solved or hacked, if you like, by a quantum computer fairly quickly. And so we need to have a solution for that. What are we going to do? And we've been working on something called quantum key distribution, which uses a sort of fundamental law of physics, which effectively means that the link would be unhackable. And we've been experimenting with that for some time. And last year, we did the first industrial deployment of a quantum secured link. So that's where the keys, the keys for unlocking the information, were transmitted on the same fibre as the information itself. And we did that in Bristol between the National Composite Centre and the Centre for Modelling and Simulation, which are on a science park in Bristol. We did that over an optical fibre that was already in the ground, so it wasn't anything special, it wasn't anything new. And we proved that that was possible. And why that's really important is, in this situation, these were organisations who were looking at really high value manufacturing, and that's a sector where the security of data is so important. In fact, without this kind of link, it wouldn't be feasible to transmit it electronically. It would need to be done, for example, by actually human transfer, by somebody going with perhaps some data on a USB stick in a locked briefcase and traveling with that data to the location. So this opens up a whole world of possibilities for some industries. And the final area I just wanted to touch on is around entertainment and around particularly what 5G can mean for that. So 5G, next generation of mobile, it has higher bandwidths. It allows more devices to be connected. In fact, we'll probably see there'll be more 5G connections to devices and sensors than there will be to people's phones. But it also has lower latency, so lower delay. And so it starts to open up a real world of possibilities of different types of applications where that delay is small enough that it's the things where it would have been an issue in the past, it's no longer an issue. So we're working in a collaborative project where we're looking at using edge-based computing, so a lot of computing power at the edge of the network, and a 5G network to really create some new types of experiences. And some of those are entertainment related. So you can see there the examples on the slide of some sports examples. So you've got that looks like a sort of MotoGP, so motorcycle racing, where you can really bring what's happening on the screen to life in a virtual way. But we're also looking at other possibilities around teaching of things like dance and potentially music, where the delay or the latency would be an issue over not other types of network, but it starts to become a possibility where you might have a dance teacher in one location and students in other places who might then be able to have a dance class together. So that is a tour through BT, how and why we do research, how we work with universities, and also just covering some of the kinds of different areas we're working in and some of our challenges. I'm going to hand over now to my colleague Anasol, and she's going to talk about a couple of specific collaborations that she's involved with Cardiff and with Swansea.
Thank you, Carol. Hello, everyone. My name is Anasol Peña-Rios, and I'm really excited of being at this fantastic event. I'm a researcher in AI and immersive technologies, and I currently lead a research project on digital twins and the future field force. And we are aiming to explore the benefits that it could bring to BT. Just to give you a brief overview of my work, there are different definitions of what a digital twin is. One of them says that it's an evolving digital profile of the historical and current behavior of a physical asset. And the idea is to collect all this data to help optimizing business performance. However, digital twins are not a technology. There is no specific solution for them. They are a confluence of several different technologies designed to deliver specific business outcomes. So they can also be seen as a framework for information management. So this confluence of several different technologies in our vision includes specific areas like IoT. Some of these areas Carol has mentioned in her presentation. So IoT sensors to enable constant data transmissions, AI to analyze this data and provide insights and make predictions. We are also looking at extended reality. This is immersive technologies like augmented reality, virtual reality, mixed reality. And we are looking at this to its visualization capabilities because they can help visualizing complex data and enable very interactive user interfaces, focusing on a human-centered design, so putting the human in the middle of all of this. And another of the underlying technologies for this is 5G, so how we can enable connection between all of these distributed elements, including the users. And well, the combination of all of these is how we see implementation of a digital twin. What are the benefits of doing this? Well, we can do real-time asset monitoring and control for decision making. We can do predictive and preventive maintenance, and ultimately we can do simulation of different scenarios. And why I'm talking about all of this? Well, you can see that all of this involves a great deal of research in different areas, and here is where we connect and we collaborate with universities and research institutes like the ones Carol mentioned, particularly to carry out some of this fundamental research. I have two particular examples of collaborations we have done with Cardiff University and Swansea University. You might think that our research only focuses on computer science, telecoms, quantum mechanics, or STEM subjects. However, we also look at broader area of research. And in this particular example, we have been working with Cardiff Business School in industrial final projects for MBA students. So we have been looking at areas like market research and case studies. For example, I co-supervised these two final MBA projects, case study for digital twins, transforming asset-intensive industry, and the second one, a market analysis of augmented worker technology and uptake in mobile workforce operations. In this, even though they are not related to technical details, they have given us insights that were valuable inputs to define strategic areas of research for this particular project. So as you see, there are many other ways of collaboration, not just on computer science. Another example I have here is with Swansea University. In this particular collaboration, we have been working with the EPSRC Center for Doctoral Training. They are building a focus on human-centered design using these technologies, and I have been attending some meetings of the stakeholder steering committee, where I had the pleasure to meet their PhD students, and I've helped them with interviews for virtual recruitment. Another part of the collaboration we do with academics is knowledge transfer sessions. So we have held a number of these sessions to gather some of their insights on the fundamental research they are doing, and also to share some of the ideas that we have. So in this one, the last one we had was November 2020, and this particular event was not just open for BT employees. We also had it open for the wider community at the Industrial Park. So it was a very engaging event, and we do this number of events with many universities. This one was particularly on data visualization techniques. So in these examples, you can see that we have different collaborations, that we have different collaborations with academia, and we are particularly pleased of our links with Welsh universities, and we hope this grow in the future. So thank you for joining us in this session, and I will hand it back to Carol now.
Lovely, thank you, Anasol. So, so that's the end of our presentation today. So, happy to open up now for questions and answers if anyone has any questions. I think they're going to appear in the chat. So,
yes.
Anytime now.
Anytime now. Yes. Well, maybe whilst we are waiting, yeah, we can talk more about some of the other collaborations we do. You mentioned PhD students. Yeah, at the moment, I'm currently supervising two PhD students. We have held a number of master projects, final year projects, focused on industrial use cases. And this one is a very good collaboration we had with universities. I've mentioned the projects for the MBA students with a different focus, not the traditional maybe STEM focus, and this is also very valuable. It gives us different insights
Absolutely. It's also worth saying that we do work with some social sciences departments as well, because it's giving that kind of human element to, what's happening with technology. Technology, it's really important that it's not something that happens to people. It's important that it's something that, people feel they're going along on the journey with, I think. So, Anasol, I think you were a BT sponsored postdoc, I believe.
That's true. Yes, yes. I was. I was a KTP, Knowledge Transfer Partnership Associate with BT, and definitely a great experience. And it led me to, well, having a position in the company and doing some of the research I love.
Brilliant.
So,
I can see a question that's appeared in the comments from Peter Kerno Ford. So Peter says, what should any uni that wants to work with you do? Well, best thing to do, Peter, is if you want to link with me on LinkedIn, and then we can have a conversation about about your interests and our interests, and take it from there, essentially. Also, I would encourage you to join the Tommy Flowers Network and come along to some of our conferences and some of our thought leaderships.
yeah, particularly the Tommy Flowers network is a very valuable resource. It's open for everyone. So I think this is very important, because when I've talked about it, a lot of people, they think is a closed thing just for BT, and actually no, it is for all companies in also academia students. And now that it is virtual, well, it's easier for everyone to join. So absolutely, there's a lot of very interesting content going on there.
Thanks, Anasol. So are there any more questions? Oh, lots of questions in the Q&A session. I can't see the Q&A session.
Oops.
I'm just wondering.
I cannot see it. How we can do that?
I'm just hoping that Nick can hear us and he's going to give us rescue. Oh, hang on, I can see something. Apologies. Oh, Nick's saying he can't see the questions either. I wonder if somebody would be kind enough to type them into the comments so that we can answer them. I wouldn't like them to go unanswered.
Bit of a technical.
I think as presenters we have a slightly different view to the audience, and so that makes it yeah. That's what I mentioned about the human aspects of technology just now. That's that's a good example.
Yes, yes. There's always room for improvement.
Absolutely, absolutely.
Okay, they are coming.
Oh, are there any areas of research you particularly want to grow? So yes. So I mean, AI, and we mentioned that that's an important area for us, but it's going to stay as important, and if not become more important. So I think that is an area absolutely that we want to grow. And in terms of other areas, obviously, quantum computing. I mentioned quantum cryptography. We're just starting to see the possibilities, I think, in that space. That's another area. Another area of interest for us is in future materials. So it's kind of understanding, what new materials might come along that could completely revolutionize our business. So it could be in replacing a material we use somewhere already. It could be that it could make, switches in our network work much faster. It could be materials that could be used to make different types of receivers or transmitters that work very differently or more efficiently. It could be, materials that can withstand heat, for example. So we and many other businesses spend a lot of money on, cooling in data centers or in our exchanges so the equipment doesn't get too hot. So one thing we're always trying to do is improve the way that we cool things, but maybe we should look at the flip side of that, and the answer could be, well, why don't we design things that can run hot and it doesn't matter? So that's just a few examples of some of the areas there.
Well, if there is any other question, yeah, it seems that we are having a bit of an issue with the Q&A chat window. So if you could post it in the comments.
Yeah, any other questions?
So, Carol, you mentioned that you are at the moment also working on the Tommy Flowers.
That's right, yes.
So maybe it would be good to remind the people when and how they can join.
So and if you Google Tommy Flowers Network Conference, it's happening today, tomorrow, and Wednesday. We're looking at smart connected manufacturing. So we're looking at how things like 5G and AI and cybersecurity come together to really enable, in the fourth industrial revolution. So, much smarter manufacturing. So we've had a great session this morning with a number of people sort of setting the scene. And we've got a session tomorrow where some of the high value manufacturing catapults are going to talk about, what they're doing. And then on Wednesday, our final day is going to be a bit of a look forward into some of the kind of new technologies that are coming along that might make a real difference in this sort of space. But all of that is it's all recorded. So if you can't make it on the day, then you can absolutely catch up with it, because obviously I know many of the audience will be watching Wales Tech Week this week, and I wouldn't want to distract you from that. So. Oh, there's another question here. Do we work with other businesses on joint projects? So yes, we do. So we work in a number of different ways with other businesses. That could be within kind of the formal collaborative projects that you get through, say, the EU or through organisations like Innovate UK. But we would also work sometimes, kind of bilaterally with another organisation if we had, say, a problem in common, and that might be just with that organisation, or that might be with that organisation and some academic partners as well. Obviously, generally that would be an organisation that we don't compete with in whatever the particular problem space was. Something else has popped up. So it looks like there aren't any other questions. So just checking a last call for questions. Otherwise, I think it's probably everyone's keen to get off and have some lunch. No. Okay. In that case, I'm going to say a huge thank you to you all for joining us, and thank you to Anasol as well, my co-presenter. And if you want to continue the conversation, please do find us on LinkedIn, link with us on LinkedIn, and we'll be happy to discuss any kind of collaboration or any other questions that you might have. So thank you very much for joining us, and I hope you enjoy the rest of the conference.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.